Many of the old security risks that we're already familiar with, independently of where the application is hosted, still apply. So think about all these various different risks that we see in software. Things like typical web app security risks, SQL injection, cross-site scripting. They really don't change just by moving into a cloud-based environment. You still need to deal with the problems of insufficient access controls or people using weak credentials. Co-tenanted elastic computing running on someone else's cloud doesn't change any of that. Your applications are still going to use frameworks which may have vulnerabilities that may be exploited and lead to data leakage or data breaches. And of course, those could come via unpatched software as well. And even if you get all that right, there's still the risk of denial of service, and attackers simply bombarding your application with malicious packets such that it can't serve legitimate requests. All of this stuff has been a problem for years, and none of it changes just by putting apps in the cloud. I wanted to start here simply because it's a point of familiarity. If you've been working in information systems before, you'll be familiar with much of this, and it still applies regardless of whose cloud you put it in. Now later on in the course, we'll talk about some of the things that cloud can do to help mitigate these risks, and indeed there are some options which were not quite as easily accessible in the traditional model. But certainly these are very familiar risks that will follow software into the cloud environment. Let's move on now and talk about something that you do need to give quite a bit of thought about when you move into the cloud, and that's data sovereignty. Let's start here with the definition. And in very simple terms, we're just talking about where the data exists. What country or possibly jurisdiction does that data reside in? Now, this is an important question because very often when we think about the cloud, we don't necessarily give a lot of thought to where the data actually exists. It just goes up into this great big amorphous blob, which is a highly elastic, scalable cloud. You put data in there and you pull data back out. You never actually see the machines or have any sort of direct physical connection with them. Now, one area where you may consider location is in performance. You like to try and put the service as close as physically possible to the consumers of it so that you reduce latency. But with regards to data sovereignty, we're usually more worried about things like whose laws apply to the data. Is it even legal to put the data in a particular country? And that's where things get a lot more complex. I'm going to go and touch on some of the implications of where data actually physically resides in a moment. But first of all, let me just give you a quick example of what I mean by the geographical distribution of cloud. This is Microsoft's Azure status page, and one of the first things you'll notice here is the map. There's a lot of Azure data centers spread across the globe. And in fact, if we scroll down just a little bit on this page, we can see locations that spread across the world. Organizations building applications that they want to put in Azure's data center, and certainly many other big cloud providers offer many different geolocations where you can put applications. But organizations considering using a service like Azure need to choose where they want to physically locate the data. But it's not just data that drives the decision. Part of it is based on what services are available where. So for example, if we scroll down a little bit, we'll see that a service such as Service Fabric is not available in many different locations. So for example, if you really wanted to put your data in Canada, you wouldn't have access to Service Fabric. You could get it in the East or West US, you could even get it in Australia, but you can't get it in Canada. Can't get it in West India or South India or Central India or a bunch of other places either. So cloud providers don't necessarily have parity of services in every single one of their data centers. So there's one factor that influences where you're going to put data. Now that's a decision based on where services do or do not exist. Let's go and look at some issues which are a little bit more complex. In 2013, we saw the Edward Snowden leaks, troves and troves of documents out of the NSA. And many of those documents pointed to very aggressive and in some cases even illegal oversight by the US government. Now this started to make things very difficult on cloud providers because we saw headlines like this. So think about what this means. Consumers of cloud services, many of which come from US-based companies, are concerned that a foreign government may be able to access their data. This is why sovereignty is so important, particularly in regions such as the EU, where they've got some pretty strict laws on privacy and how data is handled. They were understandably very worried about putting their data within the borders of a government that had demonstrated such broad access to such a huge range of personal information. Now, this is the issue that really started to drive discussions about data sovereignty. And in fact, as you see in this headline, it was becoming so important to businesses that many of them favoured the importance of the control that they could retain over their data instead of the performance of the service itself. And as the headline here says, where does this leave the post-Snowden US cloud market? Well, for one, it started to change the discussion about where we should have services, and we saw things like this. Suddenly, the location of cloud services was becoming really, really important. And again, particularly when we talk about Europe, we saw the emergence of more services based on European soil, because that data sovereignty issue suddenly became enormously important. So now that we understand some of the sorts of issues that people are concerned about with regards to data sovereignty, and having just looked at how Microsoft spreads some of their Azure data centers around the world, let me jump over to the Azure regions page and show you something else interesting. This page talks about where you can get access to Azure data centers. And if we scroll through a little bit, we'll see a bunch of those locations listed here. But here's what's interesting. As we scroll down towards the bottom of the page, you start to get a bit of an appreciation about how the physical location of the cloud service does actually have some other implications. So for example, if you want to use Azure's cloud in Australia, you have to be a customer with a business presence down here or in New Zealand. You can't be a US-based organisation without any presence in Australia and put your services in our cloud. Now, there probably wouldn't be much point either. You're putting it a long way away from where your customers most likely are. But the point here is that we do have these geographical restrictions. Azure is also now available in China, but there are some very onerous restrictions about who can use the service there. But this last one is particularly interesting, and that's the case of Germany. And in fact, what Germany has is a data trustee model. The customer data remains in Germany under control of T-Systems, or Deutsche Telekom company. And the express objective of this is to ensure that other nations, such as the US, which is obviously where Microsoft is based, can't access the data. T-Systems controls it. They're this data trustee that Microsoft talks about here. Microsoft and other big cloud providers are very aware about the trust issues of data being hosted in cloud services which perhaps don't originate from the same country or region where the consumers are. And in fact, these providers are now going to great lengths to demonstrate their independence of government control in their home countries. Let me give you an example of that. This particular case here, which has become known as the Microsoft Ireland case, is a really important precedent of how data hosted with a cloud provider in one country should not be able to be accessed via the legal system of that provider's home country. So in this situation here, we have a case where there's a New York District Court judge who's asked Microsoft to provide emails that are stored in their data center in Ireland. Microsoft was happy to give the court data which was based in the US within the jurisdiction of this court, but they refused to hand over any information that was based outside that jurisdiction. So this was data based in Dublin in that Irish data centre. Now this may only be a case about one individual and some emails, but it's an enormously important precedent. And it's not just important for Microsoft, but it's important for other cloud providers and indeed consumers of these cloud services, because it's demonstrating that the data sovereignty, in terms of where that data actually resides, is more important than the nationality of the company providing the cloud service. Microsoft, Google, Amazon, everyone wants to be able to show that if someone in Europe puts data in their data centers in Europe, then it will be protected under European law and not made accessible at the whim of a judge in a foreign country. Data sovereignty is a complex topic. There's all sorts of other regulatory considerations, not just what country it resides in, but things like who actually controls the services, who could gain physical access to them. For example, can you put data in a cloud in your own country if the cloud is managed and operated by staff in another country? It is a complex area. And the point I really want to make here in this module about organizational security considerations is that what the cloud changes from the way you might be used to hosting systems is that you've got to think not just about where the data resides, but who controls it and whose government controls them. That's a complex yet highly important topic. Let's now move on and talk about something a little bit different, and that's doing compliance assessments on cloud providers. Doing any sort of compliance assessment on any sort of hosting provider is normally not a simple task. Indeed, it can be a very bureaucratic, paperwork-laden process. But when we start talking about how that's done on cloud providers, it starts to become quite complex. Certainly, it's something I went through many times in the corporate environment, and it was never simple. There was always a lot of to and fro, and ultimately a lot of compromise as well. And in this clip, I want to talk about some of the things that you need to consider when it comes to assessing a cloud provider. Let's start with some of the information that can be a bit difficult to get from them. So for example, something as simple as a physical address. I've seen cases where the organization involved would expect that a hosting provider would simply give them the address of where their data center is located. Yet as this organization started to transform into the cloud, I saw reluctance from cloud providers to provide that information, because often it is part of their security posture not to disclose the physical location. Now this might be something which we could refer to as security through obscurity. Let's just not tell them where the data center is, and that might reduce the risk of someone finding it. But be that as it may, this is the way some cloud providers choose to operate. And this is a piece of information that can be difficult to obtain. Certain internal procedures can also be difficult to garner from the cloud provider, and they often don't want to disclose this information for a variety of reasons. Sometimes there's a competitive advantage in their particular processes. Other times they feel it may put some of their defenses at risk if they were to describe how these procedures work. In fact, that's often the rationale for not wanting to disclose certain security defenses. For example, it's very difficult to understand precisely what sort of distributed denial of service defenses a cloud provider has. And it does make sense, because were that information to become public, that could be used by an adversary to try and circumvent those controls. Certainly, that is the rationale of cloud providers that don't like to provide these pieces of information. Now, for organizations doing compliance assessments, this becomes a difficult task because you now need to meet somewhere in the middle. They need to gather enough information to be confident in their choice of cloud provider, yet also not exceed the levels of information that the cloud provider themselves are willing to provide. However, cloud providers are usually happy to provide quite a bit of information about other aspects of their security profile. Let me show you what I mean. Just as cloud providers try to get economies of scale from having large rollouts of infrastructure, they also often try to kill many birds with one stone by demonstrating the compliance standards that they meet. So for example, in Microsoft's case, in their Trust Center, they talk about a number of different standards they comply to. And as I scroll through this list, you'll see that many of these are regional standards or standards implemented by an individual country, but others are very well recognized international standards or requirements. So things like FIPS, HIPAA, and PCI. And in fact, if we have a look at PCI, we can see that Azure is compliant with PCI DSS version 3.1, which of course governs the way payment cards need to be stored, processed, and transmitted. On drilling down into their PCI page, we can see quite a bit of information about the compliance level they've achieved. But that also includes a bit of information here about the actual services for which they've achieved PCI compliance. Now, this might look like quite a comprehensive set of services, and it is, but it's also not everything. Just putting your things in Microsoft's Azure cloud does not make them PCI compliant. Not only are there certain services that haven't achieved that compliance, but of course you can still make an application non-compliant even when it's placed inside a PCI DSS compliant environment. You can still mess up the compliance. But the point is that even though you may not be able to get all the same answers around compliance assessments from a cloud provider, you'll very frequently find quite a robust set of other standards that they've reached. And they're usually very happy to make those documents public too. Let me show you one more thing before we wrap up this piece on compliance. And it's about what happens when cloud goes wrong. This is a story from down here in Australia in 2011, and it relates to an Aussie hosting provider that was previously known as Distribute IT. They suffered a really serious attack, which, as the story says here, effectively left the company's servers unrecoverable. They lost all of their client sites, all of their data, all of their backups. Gone forever. This clearly had a major impact on Distribute IT. They had to shut down, but it also had a massive impact on those who had chosen to use this cloud provider. This is precisely the reason why organizations want to do compliance assessments. They want to establish with some degree of confidence that the provider they're putting their data in isn't going to suffer a fate the same as Distribute IT. Now, you can never be 100% certain about this. There is no absolute position of security. However, this has become almost the canonical reference for why a process of assessment and verification of which cloud data should go into is important. So that's compliance assessments. Let's now move on and start talking about penetration testing. Penetration testing of applications is a pretty normal process for many organizations, and indeed it's often a stage gate before that application can go live after it's built, or very often after any modifications. The problem, of course, is that when we're talking about penetration testing an app running in someone else's environment, we need to be conscious of not only the potential impact of those tests on the cloud provider, but what their policies are around how that testing should be done. Now, organizations like Microsoft usually have pretty good guidance about how pen testing of apps can be done. Microsoft has a good post on it here, and effectively what they say is, yes, pen testing is fine, but there's a couple of caveats. One of those caveats is that you shouldn't be doing any form of denial of service test on the application. And it really makes sense because your application is sitting there in this cloud environment that by its very nature has other people using the same environment. Denial of service attacks often saturate infrastructure such as gateways, firewalls, routers, other pieces of equipment, which may also adversely impact other tenants in that same environment. So denial of service attacks are out for pretty much every cloud provider. Microsoft has a bunch of additional information on the penetration testing overview page. It's not particularly complex. You can see here there's an initiate notification for testing, acknowledgement from Azure, and test completion. So what they're actually asking here is that if you want to run a penetration test, let the Azure folks know. In fact, further down the page here, there's a link to create a testing request. It's not exactly complex. There's a request for some contact details, when you want to do the test, and then a description of what the test will be, where it will come from, and what sort of resources you're going to test. It's a pretty straightforward form. So certainly, penetration testing of applications running in the cloud can be just fine. You've just got to stay away from the things which could actually adversely impact others in the cloud, so namely denial of service attacks, and let the provider know, because very often cloud providers will have other defenses which they may not be willing to tell you, per the previous clip, to try and protect your assets from genuinely malicious actors on the web. So that's penetration tests driven by the client. Let's go and have a look at some commercial considerations for organizations moving to the cloud. Let's just touch on a few things quickly here in terms of what are some of the commercial considerations an organization needs to have when they're considering moving into the cloud. And one of them is, what happens if the cloud provider is bought by someone else? What happens if there's an acquisition? That may not be too likely with some of the big cloud players, but what about those smaller to medium-sized ones? If they're acquired by another organization, possibly an organization in a different jurisdiction, a different country, what might that mean to the consumer of the service? What happens when there are pricing structure changes? In the current climate, we're normally seeing cloud services decrease in price, which most people are pretty happy about. But what happens if the way the pricing is done changes such that it adversely impacts the consumer? This is certainly a feasible option, and in fairness, it's not just a cloud option. We've always had this risk when we're consuming any sort of service, but that elastic nature of cloud tends to predispose it a little bit more to changing. Another one that you do really need to be conscious of in terms of commercial considerations is the risk of lock-in to the provider. So for example, we're seeing many cloud services which are bespoke implementations to that provider, bespoke storage implementations, or message queue implementations, or other services which can be fantastic in the context of that provider, but may not transfer well to another provider if you decide to change later on. So for example, because they're acquired or their pricing structure changes. So how much lock-in are you going to have to the cloud provider that you choose? That's a very important commercial consideration. Inevitably, for each specific organization, there'll be many other commercial considerations that need to be kept in mind. But these are three of the big ones that come up time and time again in discussions when choosing a cloud provider. Now I want to go and look at one more thing in this module, and it's something which is actually quite a concern to many organizations, and that's shadow IT. Even if you don't recognize shadow IT by name, you've probably recognized the symptoms of it. Someone in the accounting department who has an Access database that manages all their books for a certain part of the business. IT had nothing to do with it, but somebody knew a little bit about how to whip up an Access database, and now the organization has become really dependent on it. But it hasn't gone through any of the normal organizational approval processes. It doesn't adhere to the coding standards or the security patterns or any of the things that are important to building robust and sustainable software. Shadow IT is not a new risk. It's not a risk specific to the cloud. It's one that we've had for decades now. But what changes with the cloud is just how easy it is for anyone to turn around and stand up services that run for an organization but totally circumvent all of those IT controls. Let me give you an example. This is DigitalOcean, and they've become really popular in recent times for being very cost effective and very fast. You can get an SSD cloud server up and running in only 55 seconds. Now that's very enticing, and it exemplifies that cloud characteristic of on-demand self-service. This is what we want out of a cloud. But of course, by making it so easily accessible and so fast to spin up, just about anyone can do it. So from a shadow IT perspective, the risk we have now is corners of the organization standing up their own cloud implementations, often without any engagement whatsoever with IT, and totally skirting around the organizational controls that should govern the way things like the cloud is actually stood up. The very thing that makes the cloud so attractive is the same thing that's increasing the risk of shadow IT. Let's go and talk about some ways that we can manage this better. Here's a few things to think about when it comes to reducing the risk of shadow IT. So first of all, actually understanding which cloud resources are already in the organization. You may find that you already have shadow IT. Go and find out where those pockets of cloud actually exist. Now, of course, you also want to know who's actually creating them. Remember that cloud services are not necessarily virtual machines running somewhere in an IaaS sort of model. There could be SaaS implementations. For example, is someone using SurveyMonkey? Perfect example of software as a service. And has that actually passed through the appropriate organizational approval controls? It's not just who's creating these services, but who's then using them. So how much of the organization now has a dependency on these services? The difference between a few people in one department and hundreds of people across the organization is going to determine how you try and unify these little pockets of cloud into a more cohesive organizational strategy. Now, you may well find that there are pockets of the organization where cloud exists and it does actually adhere with compliance and security policies. But equally, the ease of standing up these services means you'll probably find corners of the organization where there's shadow IT cloud that doesn't adhere. I've seen many cases of shadow IT in the corporate world over many years. And one of the things that always struck me is that they're usually solving an actual business problem. Most of the time, shadow IT doesn't pop up without a good reason. And what you'll usually find is that there is some discrete business problem that people standing up these services are trying to solve. So what I'd encourage you to try and do is when you see shadow IT pop up in this fashion, is to think about what the underlying problem is. Why is there shadow IT here? Why couldn't they get this service through the formal IT channels of the organization? So in a case like cloud, if someone's going out and getting virtual servers from DigitalOcean in only 55 seconds, what can the organization better do to make those machines more readily accessible within the constructs of a formal cloud strategy? Clearly the technology exists. DigitalOcean can do it in 55 seconds. How can you help the person that really genuinely needs a server quickly get that machine without skirting around the organizational controls? So that's shadow IT, and indeed that is the organizational security considerations module. Let's go and summarize it briefly. Let's start here. This is the administration interface for Microsoft's Azure Cloud Platform. I'm logged into this interface under my identity, and I want to give you just a bit of a sense of how important these sort of facilities are. Administration interfaces like this are normally publicly facing. Anyone with an internet connection can access it. Let's take just a few minutes to talk about some of the damage that can be done if an attacker gets hold of an administration interface like this one here. So for example, they could start to have a look at all the services that I'm running under my cloud account. Services such as websites, or as Azure calls them, app services. They'd be able to drill down and have a look at some of the individual websites I'm running. Websites such as Hack Yourself First. Now this is a website that I've used in many of my different Pluralsight courses. It's a deliberately vulnerable website that I use to demonstrate typical web security risks. It runs up here in Azure, and were an attacker able to compromise my administration facilities, this is what they'd be able to see. But perhaps more importantly, they'd be able to see things like my app settings. These are all available via the portal because as that infrastructure is virtualized and abstracted away into this thing that we now call the cloud, and in fact in this particular case we're looking at a platform as a service implementation of a website, all of the administration facilities are readily accessible in the browser. So for example, as we scroll down through my application settings, we'll see some name value pairs here, actual app settings. And very frequently app settings will have secrets in them. Now I've just put a little example in here, an app setting called my secret and a value called this is a secret value. However, very often we'd be looking at things like API keys, credentials, other secrets that are meant to remain secret and not be accessible to an attacker. Another good example of that is down just a little bit further, the connection strings. This gets you access to the database. These are my real connection strings in this particular web application. And as you can see, Azure by default has hidden them for security reasons. But an attacker with access to my administration facility would be able to take that connection string, make a connection to the database, and extract any data that the account in the connection string had access to. Along with accessing things like my app settings and my connection strings in here, an attacker could access all sorts of other cloud constructs that I might be using. So for example, I use Azure's storage implementations, blob storage, table storage, message queues. All of that is accessible when you have access to the portal. Accessing information that I already have in the portal is one particular class of attack, and certainly that is the thing that most people are most worried about. But an attacker can also do damage by doing something like this. Let's go and add a new resource under this account. And we might just go and add a virtual machine. We'll choose the latest available version of Windows Server, and we'll jump down to actually create that machine. Now I'll just drop some sample values in here because it's the next screen that I really want to show you. So those ones will be okay. Let's now click OK. And now I'm going to choose the machine size that I'd like to create. Let's go and see all the ones that are available. Now let's say, with my attacker hat on, I decide to scroll down until I find just the right machine to create for my target. A GS5 machine sounds about just right. Why is this right? Well, because it's going to cost the person who owns the cloud service over $8,000 a month. This is a different class of malice altogether. This isn't about taking my data, although certainly if they have access to the portal, that's one of the things they could do. But this is about causing me economic duress. We're going to look at something very similar shortly, which is economic denial of sustainability. But one of the risks that is run with a portal like this, and indeed all the cloud providers do have publicly facing portals like this, is that it is exceptionally easy for costs to escalate. We could spend a lot more money than just $8,000 a month, very, very simply. So from a cloud computing risks perspective, one very, very tangible risk is that costs can escalate out of control enormously quickly. Whether that be because an attacker goes through and provisions a machine like this, or even because the individuals responsible for managing the resources over-provision or simply make a mistake and choose the wrong-sized resource. We didn't have this problem when we were ordering physical infrastructure and having it shipped on site. We had many other problems, no doubt about it, but we really didn't have the same problem of someone going in and ordering up infrastructure that causes a huge cost to be incurred almost instantaneously as they're in there in the portal. Administration facilities like this are extremely valuable. And later on in the course, I'm going to talk about how to harden the cloud. And one of the things we'll look at is how we make sure that this particular resource is as well protected as it can possibly be. For now though, let's have a look at a few of the different ways that an attacker might actually gain access to the administration facility. Let's talk about just some of the ways that an attacker can gain access to an administration facility, and then of course access private information or run up your costs. So for example, if someone with access to the administration facility reuses their credentials, those credentials may be compromised from another service. Certainly we see this happen many, many times with data breaches, and then reused to access the administration facility of the cloud provider. So in a case like this, the username and the password to a portal such as Microsoft's is literally obtained by the attacker and then reused in the administration facility. In a case like this, there's clearly fault on behalf of the person who owns the account. Another possible attack is something like session hijacking. Now this is quite different because what we're talking about here is what would often boil down to a flaw in the administration facility software. So for example, if they weren't flagging their cookies as HTTP only, and they had a reflected cross-site scripting vulnerability and an attacker was able to convince the victim to follow a link, we could have a case of session hijacking. I have an entire course on Pluralsight called Ethical Hacking Session Hijacking, and that goes through many of the different ways that this can happen. The reason why I've included it here is that this demonstrates that there can be weaknesses in the administration facility itself, which leads to a compromise. Now this is important because it recognizes that those with access to the portal could do everything right, and that ultimately these portals themselves are just more web software that can have typical web vulnerabilities. A different risk again is exposed keys. And what I'd like to do here is actually give you an example of where this happened. Let me show you. In 2015, a web developer accidentally made a GitHub repository public. The background is that Visual Studio 2015 behaved in an unexpected fashion when he attempted to create the repository. But be that as it may, he ended up with this repository going public. The repository included an AWS key, and that key was very quickly stolen by someone monitoring GitHub for public repositories and used to provision resources that allowed the attacker to mine Bitcoins. Now very quickly he saw his bill run up to $6,500 within hours, which speaks to the previous point I just showed you in terms of how easy it is to provision very expensive resources. All of this was possible because this AWS administration facility, just like Microsoft Azure's and just like so many other cloud provider dashboards, sits out there facing the public. It is literally one key or one set of credentials away from an attacker having full control of it. So that's exposed keys. Let's go back and look at one more possible cause of administration facility compromise. Social engineering. This is another topic which I have an entire course on, ethical hacking, social engineering. And in there I talk about many different ways that valuable pieces of information can be extracted from targets. In the context of gaining access to an administration facility, that target could be the individual whose account an attacker wants access to. But it also could be someone on the support side of the cloud service itself. Let's move on and take a better look at social engineering, because in the context of administration facilities of cloud services, it's a really important topic to be aware of. Let's start here with a definition slide from my social engineering course. And this is a class of attack which is quite simply psychological manipulation. We're trying to convince someone to do something or disclose something which they wouldn't do under normal circumstances. So for example, you have almost certainly seen emails like this. This is just classic phishing. In this example, it's PayPal. The attacker would like to have you believe that your account has been limited and you must now go and follow that link in order to restore it. Now inevitably behind that link there will be a request for information, almost certainly username and password, often other personal attributes or financial information as well. Now have a think about what this means in the context of gaining access to administration facilities. If an attacker was sending emails like this, let's say from Amazon, saying that an AWS account had been limited and you must go and resolve now, how likely is it that they would obtain some valuable credentials? Certainly, it is a risk. But the risk is not just one of obtaining credentials from the administrator of the cloud service. It actually extends much further than that, and I've got a good precedent to show you. This is a story from 2014. And it relates to how the owner of the Twitter account N, so just one letter, it's just @N, lost his account in part due to social engineering of GoDaddy. The relevance of this when we're talking about hijacking of services such as administration facilities is that obviously GoDaddy plays a really important role in how online assets are protected, particularly when we're talking about how domains are managed. So what we're going to look at here could just as easily extend to the administration facilities of cloud providers. Now, what happened in this case is that the attacker obtained a small amount of information about the victim from PayPal. In fact, what they managed to get out of PayPal was the last 4 digits of the victim's credit card. With that information, the attacker was able to talk to GoDaddy and convince the support operator that the attacker was actually the victim. This wasn't because the attacker had exactly the right information. In this particular case, the attacker explained how GoDaddy actually let him guess 2 of the digits of the victim's credit card that were required to verify his identity. Just let him guess. So inevitably, the attacker convinced the operator that he was actually the victim, probably through some very typical social engineering tricks, and perhaps a little bit of sweet talking his way through to the point where the support individual at GoDaddy just wanted to be helpful. Once again, the very nature of having administration facilities for a cloud service on the public web, accessible by anyone, and protected merely by a set of credentials, does pose this risk. As we just saw, gaining access to the dashboard of a cloud service like Microsoft's Azure could have some pretty serious ramifications. We looked at the ability to go through and access sensitive information, and we also looked at how an attacker could then go and provision resources which could have a serious adverse financial impact on the victim. However, you don't need to have a compromise of administration facilities to put the victim under financial duress. Let's now move on and take a look at economic denial of sustainability. In the first module, I talked about the characteristics of a cloud service, and these included things like rapid elasticity and measured service. And these are great attributes of cloud computing. They enable us to do many wonderful things with the service. However, they also pose this risk: economic denial of sustainability, otherwise known as an DDoS attack. And what we're talking about here is the attacker trying to cause traffic to go to the site that results in the owner of the service incurring huge costs. Now, we just saw a variation of that by the guy who inadvertently published an AWS key to a public GitHub repository. But there are other ways of causing an DDoS attack to occur as well. We'll talk about those in just a moment, but let's first have a look at what sort of costs we're talking about. This is the Microsoft Azure pricing calculator, and it's a really good way of getting a sense of how much it might cost to run certain services. We're going to use it to get a sense of how much damage you could cause someone if you could get the services they're using to scale in a way that results in an DDoS attack. So for example, let's go down and we'll choose an app service. So this is Microsoft's interpretation of a website as a service instance. That's been added. Let's now scroll down and have a look at how much that might cost. We'll go and choose the standard tier, which is pretty typical for websites running on Azure, and it's going to cost about $74 a month. Now let's go over here and we're going to start adding instances. So instead of 1, we might take 2, 3, 4, maybe 5. Now we're talking about $372 a month. So the question you need to ask in terms of the risk of DDoS is, how could you possibly cause someone to run 5 instances of the service instead of 1? Well, a service like Azure will scale out automatically if it's configured to do so. Indeed, this is a very popular way of setting up a website. Set up autoscale, and then if you have unexpected success through huge volumes of traffic coming to your site, you get more instances. You pay for them, but you've got this legitimate traffic, which is a good thing. But what if it wasn't legitimate traffic? So what if the attacker was manufacturing requests to the site that caused it to scale out, not due to legitimate traffic, but due to the specific requests that the attacker was sending? What if instead the site was running on the premium tier, and autoscale enabled you to go much higher. Suddenly, those costs start to really escalate. So what could possibly cause infrastructure to scale out this way? Well, you need to think about what creates overhead on the website. So for example, many web applications will use very slow hashing algorithms, which means that every time someone tries to log in, there's actually quite a bit of load on the infrastructure. If I was an attacker trying to mount an economic denial of sustainability attack on the victim's website, I'd be issuing as many simultaneous login requests as I possibly could. That's the sort of thing that's going to drive up CPU overhead and possibly trigger the infrastructure to scale out. Let's try something else. We'll go and add some bandwidth. And then we'll scroll back down and we'll see how much bandwidth we're going to use up. 5 gigabytes doesn't cost any money. But what if it was 5 terabytes? There goes $445. And then obviously as we consume more and more terabytes, the cost goes up even higher. Depending on the location you're in, those costs can be even higher again. So for example, down in Brazil, that's actually more than double the cost for the same amount of data, simply because those bandwidth costs are higher if the service is located in Brazil. Many cloud services will actually geo-distribute applications across the globe. So if you as an attacker can cause large volumes of data to exit the customer's Brazilian instance, you're effectively leveraging your impact in terms of that economic denial of sustainability. But how would you actually do this? Because the attacker doesn't want to be incurring the same costs themselves. The reality is though, they usually wouldn't need to, because a pretty normal state of bandwidth charges with cloud providers is that you pay for egress data, so that's what we're looking at here, but you don't pay for ingress data. So if the attacker goes and stands up their own cloud service and then targets the victim by creating a script that downloads large volumes of data from that victim's cloud service into the attacker's cloud service, then the victim is seeing egress data, which has these costs, but the attacker is seeing ingress data, which frequently has no cost. They would simply go and identify resources on the website that were large images, documents, maybe movies, and then they'd download as many of them as they possibly could as fast as they could. Now that's a pretty simplistic example, and certainly there are ways that a victim could try and protect their assets from being attacked in this way. But equally, there are many different ways that an attacker can cause large volumes of data to exit a site, or a large number of requests to be sent to high overhead processors by distributing that load out in a way that's difficult to defend against. Now this isn't a distributed denial of service in the classic sense. They're not necessarily wanting to take the service down. They're just trying to make it expensive to run. So that's DDoS. Let's go and look at something a bit different now, and that's hypervisor breakouts. Let's start with the definition of hypervisor, because it really is a pretty key component of a cloud implementation. The hypervisor is the virtual machine monitor. So this is really the heart of what allows us to run multiple logical machines on top of the one piece of physical infrastructure. To better understand how the hypervisor works, let's go and take a quick look at the mechanics of virtualization. We've had virtual machines around for a very long time. In fact, you may well have run them on your own physical machine. And virtualization is a pretty key tenet of the way cloud services run. Of course, there's much more to cloud than just having virtualization. We still need those cloud characteristics such as on-demand self-service and resource pooling. But when we leverage those characteristics, we're very frequently using virtualization services, particularly when we talk about infrastructure as a service. So when we look at virtualization, inevitably we do still have a layer of physical infrastructure. Back in the first module, I showed you some of the data centers of Google and Microsoft. They're still racks of machines, and that's our underlying physical infrastructure. We then have a virtualization layer. So this is where the hypervisor is able to sit there and provide an abstraction between the physical infrastructure and then logical infrastructure that sits on top of it. So this is going to be one of our virtual machines. Now that logical infrastructure means that when you do remote into the server, you'll still see a network card and hard disks and other virtualized devices. They don't necessarily map directly to that underlying physical infrastructure, but it does mean that when you're in there in the machine, it looks pretty much like a normal operating system. Because of course that's what we have. The operating system sits on top of this logical infrastructure and it supports applications that run within there. Now when we talk about virtualization, we inevitably have multiple virtual machines that run on top of that physical infrastructure. Sometimes this can be thousands of machines, and factors such as the capacity of the underlying physical infrastructure and the scale of the logical machines that are being provided will determine how many get provisioned within that one physical machine. The hypervisor is what keeps virtual machine 1 separate from virtual machine 2, because these could belong to totally different customers, and this is much of the premise of resource pooling, that other cloud characteristic we looked at in the first module. You're going to share the physical infrastructure between multiple customers. But what happens if it goes wrong? So what happens if virtual machine 1 is able to break out of the hypervisor, which is meant to keep it as a self-contained logical piece of infrastructure, and then access resources from virtual machine 2? It could be catastrophic because you could end up with one customer accessing another customer's data. This is not a hypothetical risk either. Let me show you. In 2015, we saw a very serious risk with the Xen hypervisor. And one of the things that made this risk so serious is that this is what AWS uses. Many of the customers on Amazon's cloud service are sitting on top of virtualized machines managed by Xen. The problem with this particular risk is that it provided the potential for an attacker to break out of that one logical machine sitting on top of the Xen hypervisor and access extremely sensitive parts of the underlying operating system. Now, fortunately, this was patched very quickly by Xen and rolled out very quickly to customers such as Amazon. But it demonstrated what is probably the biggest fear most organizations have about cloud security, and that is that they're sharing resources with other customers. And indeed, this is one of the reasons why models such as a private cloud, whether that be on-premise or with a provider, are often preferred to using the co-tenanted model, which is the more easily obtainable, cost-effective model. The Xen bug is probably one of the worst we've seen in terms of the impact on the hypervisor. And even though it was patched very quickly, it served as a reminder that there are some unique risks when we run services in the cloud. Incidents such as this posed a very specific risk to organizations that had decided to put their resources in the cloud. But there's another class of cloud computing risk that affects everyone, regardless of whether they have put their things in the cloud or not. Let's go and take a look at some malicious cloud uses. Having this on-demand, self-service, rapidly elastic model that is cloud allows us to do wonderful things. We can do many, many good things with good, honest software that we couldn't do in the past. However, all of those attributes allow evil actors to do some pretty malicious things as well. So for example, cloud resources are enormously effective at mounting DDoS attacks. If you can go in there and spin up as many resources as you like, as fast as you like, that is enormously useful for flooding a target with malicious traffic. You spin up a bunch of machines in one go, and you tell them all to target a particular resource. Now, cloud providers such as Microsoft and Amazon and Google normally put a stop to that sort of thing pretty quickly, but not all cloud providers are quite so vigilant. And indeed, it can also still take a while before malicious activity like that is identified and the services shut down. Another use again is for password cracking. This is an activity which can be really resource intensive, and the upside of doing this in the cloud is that appropriate resources can be provisioned when required, used for the duration of the cracking process, and then simply discarded and the charges end. This, again, is the joy of having a measured service. Let me give you an example of that. In 2015, there was this piece, cracking a Wi-Fi WPA2 password thanks to Amazon. And effectively what they've done here is just spun up appropriate resources as required and then gone through the password cracking exercise. In this case, there was a perfect image already available in AWS, an Amazon Linux AMI with NVIDIA Grid GPU power. So this is now using graphical processing units that are available as a service in the cloud, and they tend to be enormously effective at cracking certain types of hashes. Now, of course, password cracking isn't always used for malicious purposes, but you can certainly see how it would be attractive to attackers that wanted to use the cloud to break other people's security. Let's go and have a look at another malicious use. Botnet command and control. In a botnet of infected machines, sometimes tens or hundreds of thousands of different machines, the command and control server gives the attacker a mechanism to orchestrate the behavior of the bots. Now, these CNC servers are always the target of law enforcement and security vendors alike, because if you can take down the CNC, you effectively leave the infected machines orphaned. They can no longer take commands from anywhere. Part of the joy of the cloud for a bot herder who's trying to keep their CNC servers alive is that it's just so easy to spin up new CNC environments. Now, of course, they've still got to make sure that those infected clients know which CNC server to talk to. But the very fact that they can spin up machines so quickly and then spin them up in different parts of the world with different configurations gives them a whole bunch of different options which they never had before the advent of the cloud. One final malicious use for the cloud is captcha solving. Now, this is an exercise which is done with various levels of success, depending on the captcha and depending on the value of solving an individual one for the attacker. This is an exercise that can be quite resource intensive, particularly if it's done at volume. So the promise of the cloud here is the ability to rapidly deploy instances of logical machines or services that can take on board the load involved in cracking captchas. Now, an automated machine solving captchas for you probably sounds like a pretty nice idea. But keep in mind that captchas are normally there to try and avoid automation. So they're usually there to protect systems from attacks such as brute force. So an attacker being able to solve captchas at a high rate often then puts other legitimate machines at risk. These are all malicious uses of the cloud that we've seen before, and we'll see them again as well. Let's go and take a look at just a couple of other potential risks within the cloud. Let's start here, and it's the very question that many organizations are asking themselves. What does it mean when they don't control the physical machine? Does it increase the risk? As I've said many times now, I actually don't think this is a good question. It's very black and white. Is it more risky or less risky? Because conversely, you could ask this question. Is it possible that the cloud provider could manage the infrastructure better than what the organization themselves could? That goes back to one of the points I made in the very first module, when I showed you how huge those Google data centers are and how they're able to commoditize the way these resources are managed and do so in a very professional manner. So again, just saying, is it more or less secure? Is the risk increased or decreased? Is perhaps not the right question. But let's actually touch on that concern I raised in the last slide. What can possibly happen if you're sharing infrastructure with someone else? We looked at hypervisor breakouts earlier on. Let's look at another risk related to sharing underlying infrastructure. In 2015, we saw an attack emerge that became known as Rowhammer. And what we're talking about here is a very low-level attack that goes all the way down to the way dynamic random access memory, so memory we also know as DRAM, could possibly leak charges and, as Wikipedia says here, interact electrically between memory cells, possibly altering the contents of nearby memory rows that were not addressed in the original memory access. The bottom line is that rowhammer can potentially change the state of memory outside the intended function of the process that's using it. As the article goes on to explain here, we actually saw that used in some privilege escalation exploits. Now think about this from the perspective of cloud, and in fact think back to when I talked about hypervisors. Rowhammer is an attack against the underlying physical infrastructure, not the logical infrastructure or anything else which is isolated by the hypervisor. This is precisely the sort of thing that organizations are worried about when they share infrastructure with other customers. Now I've included this down here at the end of this module in other potential risks, simply because it illustrates the fear of sharing that underlying physical infrastructure. There weren't workable attacks that were used in cloud environments that allowed one customer to start modifying or accessing another customer's data. Certainly none that became publicly documented anyway. But that's part of the concern. We know that true potential of many of these exploits are kept silent and are used in malicious ways that we may never know about publicly. Whilst there is shared underlying physical infrastructure, this is the sort of concern that opponents of cloud computing will raise. Let's look at one more, and this one is a little bit more hypothetical. In 2016, there was a study done that showed how crypto keys on a machine could be obtained by another machine in another room. And that first machine was air-gapped as well. It was not connected to a network at all. Now, what the researchers from Tel Aviv University found is that they could measure the target's electromagnetic emanations, and that alone could potentially extract the crypto keys. This obviously required some pretty specialized hardware, as you can see in the image to the bottom left here, and it did also require pretty close proximity between that equipment and the target machine. It was just on the other side of the wall. But it was significant in that the machine was actually air-gapped, and it was a very simple passive observation of how the machine was behaving. Now, in fairness, relating this back to cloud computing, it's a very long bow to draw insofar as what these guys were able to do having any impact whatsoever on the way machines run day to day in the cloud. But look at the problem this way. What many organizations are concerned about is that when they no longer have physical control of the infrastructure, they become somewhat xenophobic. They're afraid of the unknown. Now, whether that be rowhammer or specialized electromagnetic gear looking at the emanations from a machine, the feasibility of these attacks is almost a secondary consideration, because the concern is simply that it's not within their control. And often the belief is that if those machines sit within an organization's data center, attacks like this simply won't happen. But of course, there have been many attacks against physical infrastructure that exists within an organization's data center. And they might not be the ones we've just looked at here, but they've been much more classic styles of attack. Often attacks from things like malicious insiders, or actors who've managed to socially engineer themselves onto an organization's premises. They're different attacks, and this again speaks to the whole premise of cloud security being different rather than better or worse. But one thing that does play into the favor of cloud security is that when we look at cases like the Xen Hypervisor breakout, and that was a serious bug, it now becomes someone else's responsibility. And one of the positive things about cloud security is that when you use a provider the size of Amazon or Google or Microsoft, they have an almost unparalleled ability to identify, patch, and deploy defenses against these risks in record time. And that's a really good segue into talking about cloud computing security strengths. So let's go and wrap up this module, and then we'll go and look at the good security aspects of the cloud. I want to start this module by talking about distributed denial of service attacks. And the cloud can help us deal with those in a number of different ways. Now, I've got an entire course on denial of service attacks in general. It's also part of this ethical hacking series. Let me just touch on a few areas of denial of service attacks where the cloud can be very useful. And one of them is simply absorbing the attack. Now, this is part of a well-rounded, robust DDoS defense strategy. The faster you can respond and absorb attack traffic, the more time you buy yourself to figure out how you're going to fend off the attack itself. The great thing about the cloud is that we can so quickly scale in order to meet unexpected demand, whether that be demand from genuine customers because some event has happened that's made your product particularly popular, or whether it be demand from malicious actors. So for example, I can jump into this Hack Yourself First site, which we touched on a little bit earlier on in the course, scroll over, and then jump down to say, Scale Up. And what I might want to do in Scale Up is actually increase the size of the resources I'm running. So for example, perhaps rather than running a 2-core 3.5 gigabyte RAM S2 instance, maybe I want to scale up to an S3, 4 cores, 7 gigabytes of RAM. It's twice the machine. And of course, I'll pay twice as much because that is the nature of a measured service. Now, by having twice the machine, I can, roughly speaking, absorb twice the traffic. But we can go much further than that. So what if, for example, I decided to scale out? So rather than just running a single instance, what if I did this? What if I dropped down here into my scale settings, and in my target range of the number of machines, I scaled that all the way up to 10. So now not only can I scale up and double the size of the individual machine, but I can have up to 10 of them. So there's a 20-fold increase in my ability to absorb traffic. Now, of course, this may lead to the problem that we saw in the last module, which is an economic denial of sustainability, because inevitably I'm going to pay 20 times more money whilst this attack is happening. But the ability to just jump into the portal here and throw more resources at the drop of a hat, this is literally minutes to get this up and running, buys me time. And in terms of fending off a distributed denial of service attack, this is an enormously useful feature to have. You can't do this in traditional infrastructure. You can't turn around and say, I'm going to increase the capacity of my on-premise infrastructure 20 times over in the space of minutes. Not unless you've got a lot of infrastructure sitting around there running at idle for most of the time. So that's absorbing the attack. Let's go and look at actually fending it off though. In Microsoft's Azure Network Security documentation, they talk about their ability to protect against DDoS attacks. Now, as I mentioned earlier on in the course, Microsoft and others don't talk specifically about how they fend off these attacks. Obviously, the concern here is they don't want to give anything away that might be useful to the attackers. But the real observation I want to make here is that when you're using a cloud provider the scale of Microsoft, or Google or Amazon or any of the big players, they become very adept at protecting large numbers of customers from distributed denial of service attacks. Now, part of the way they can do that is that they themselves have a huge ability to absorb attacks because they've got mammoth infrastructure, but they also have very sophisticated devices. This is part of the value proposition of having such large-scale players actually hosting your applications. In Microsoft's case here with Azure, they'll protect applications from attacks originating from outside the Azure environment, as well as also protecting applications and services from attacks which might actually originate from within Microsoft's own network. It's entirely feasible that a malicious actor could stand up their own Azure services in order to try and target someone else's services. So a provider like Microsoft has got to be conscious of a threat which is quite different to other networks, in that a distributed denial of service attack could originate from within their own environment. So again, as I mentioned earlier, there is DDoS defense. They don't give you a lot of detail about it, but it is something that you get out of the box as part of the service. let's have a look at one more really neat DDoS defense that's available in the cloud. This is Cloudflare, and I have an entire Pluralsight course just on how to use Cloudflare to improve the security position of your websites. It's called Getting Started with Cloudflare Security. There's a lot you can do with Cloudflare, and one of the beautiful things about the platform is that it is just a 5-minute setup that you can do entirely for free. The reason it's so fast and so cost effective is that Cloudflare is a cloud-based service to help secure and optimize your website. In that Pluralsight course, I go and create this service, cloudflareonazure.com. And in here, I go through the process of configuring the firewall. Now, the neat thing about the way Cloudflare works is that when you go through that 5-minute setup process, you route your traffic through Cloudflare's infrastructure. So when a visitor browses to your website, their traffic is actually going through one of Cloudflare's many distributed nodes around the world. And each one of those nodes is able to inspect the traffic, assign a risk rating to it, and then decide how to deal with it. So for example, does it just let it through? Or does it possibly challenge the visitor with a CAPTCHA, which is the sort of thing you'd do if the site was under a distributed denial of service attack. In fact, you can go and tweak your own security level just here. And as you can see in the drop-down list here, one of the options is I'm under attack. There is a DDoS attack happening to my site right now. Let's up the defenses. Let's maybe challenge some more traffic to make sure that we're only getting legitimate visitors coming through Cloudflare's infrastructure. Services like Cloudflare are enormously effective because such a huge portion of the internet travels through them. Cloudflare sees about the same number of requests every month as Facebook does. It's ginormous, and because it sees so much traffic, it's gotten very good at identifying the differences between good traffic and bad traffic. Now, this is a great example of what I meant in the introduction when I said think about the ability to do security as a service. This is a perfect example because you could never do this as effectively yourself, just looking at your own traffic and standing up the infrastructure to try and fend off malicious DDoS traffic. You can never do it as effectively as a global player like Cloudflare. So that's a good starting point for cloud computing security strengths. Let's move on and look at something that's a little bit more people-orientated. Let's look at server administration as a service. We saw this guy in the first module of the course, the server administrator who walks around their own data center, managing their own machines for their own organization. In times gone by, this was always the way data centers worked. We had them within the organization and certainly had them managed by the organization's people. And if it wasn't people directly employed by the organization, it was the organization paying large sums of money to outsourcing providers who'd send their people into the organization's data center. It was very hands-on in terms of the company running the data center needing to properly equip it with skilled staff. Server administration is not a simple task, it is a specialized skill. And indeed it needs specialized people, which is a costly exercise. What the cloud does is starts to commoditize the process of server administration. So rather than saying, we need individuals, warm bodies, who'll come on site and manage physical infrastructure in our data center, now we're saying, we just need a service. We need infrastructure as a service where we've got virtual machines running, and then the cloud provider will provide the warm bodies that look after it. There are still humans there looking after the infrastructure and managing things like updates to the environment, but they're massively commoditized and they work at a scale much greater than what most organizations do. By using cloud services, you get to leverage that massive economy of scale that Microsoft and Amazon and all the other ones have. But let's take a moment just to have a look at some of the challenges we have when we do have our own server administrators managing our own data centers. Over the years, I've seen a lot of good server administrators and a lot of bad ones. I've seen the challenges of actually managing a data center in an organization, and there are some common patterns which tend to arise. So for example, I very often see inexperienced people managing servers. People who simply haven't spent enough time yet to be in charge of such a critical piece of infrastructure for a company. Now, very closely related to that is underskilled individuals. So perhaps individuals that do have a technical competency, but it's just simply not a competency in managing server environments. I've seen many times where developers end up being sysadmins, and I've certainly seen a lot of cases where that has led to some very unpleasant consequences. Also closely related to this skills issue is how security conscious the individuals are. So do we genuinely have people that not only have the years of experience and the relevant skills to manage the environment, but actually put security at the forefront of what they do? Are they really conscious of all the risks that they need to protect their environment from? These three are all pretty closely related, and certainly individual competencies and training go a long way to addressing them all. The point here, though, is very frequently organizations fall short in all these three areas. Whereas when you go to a cloud provider, you know that they've not only set the bar very high for these individuals, and part of that is because the stakes are so high when they're managing so many customers, but they've also got enough formality and process in place that if anything does go wrong with an individual, there are extensive safeguards in place to mitigate that risk. Now, another problem I've often seen in the traditional on-premise local server administrator sort of environment is how long it takes patches to be applied. Especially in years gone by, the process of applying a patch was a very drawn-out exercise. There has to be documentation and testing and rollback plans. And this was necessary because patches would break things. But this model starts to change in a cloud environment because the cloud providers are working to ensure consistency of service, and the patch is an abstraction beneath that. So if we think back to the diagram in the first module, particularly around those platform and software as a service models, patching of something like the operating system or the runtime is well and truly the responsibility of the cloud provider. The customer has no control over it, and the cloud provider has to ensure that they keep the platform stable as they apply those patches. It's a very well-tested, well-proven, often repeated process, which means that good cloud providers can patch their systems, often against things like critical security vulnerabilities, much faster than in that traditional on-site model. Now, another problem that I've often seen in this old model is being understaffed. People are expensive. People leave. Unexpected events happen. It can be really difficult to have the right level of staffing on a consistent basis. And the problem then is that if you don't, so if there's an event, for example, which requires extra attention, it's really hard to scale people. It's not a simple task to simply say, hey, we need someone else here today or tomorrow, and we need them to hit the ground running and be productive in our environment straight away. Running a data center is not an easy task, and everything you see here is part of what you get as part of using a cloud platform. These are all the things that are bundled into the cost of buying that commoditized service. Now, often organizations aren't even factoring some of these things into their ROI, but it's a really important offering, and it is a cloud computing security strength when suddenly all of these things are no longer a problem. So that's server administration as a service. Let's now go back to something a little bit more technical. Let's talk about account management as a service. Just about every system or application we work with has some concept of account management. We have records that we authenticate against that identify us and then consequently allow us to access certain systems. Now, this may be account management which is manually built into the application, or it may be account management of a nature that allows all the employees in the company to log on every day. Account management is something that is available now as a service. In Microsoft's case, it's Azure Active Directory. So think about the Active Directory that you'd traditionally have on-premise, with those server administrators looking after it, as we just saw in the previous clip. And now imagine that you could put that in the cloud, and it simply became a commoditized service. You paid for as much as you used, you increased the scale when you needed, and someone else looked after it for you. They'll charge you. That's the very nature of cloud. That's the measured service. But it starts to move something which really can be commoditized into a service, away from the organization's responsibility, and offers it as a service. Now, as you can see here, there are a bunch of really neat things that you can do with a service like Azure Active Directory. So for example, enforcing multi-factor authentication. And not only that, but you can integrate it with your on-premises Active Directory as well. So this goes to the earlier point of how our cloud-based security solutions may actually be a bit of a hybrid. It's not an all or nothing sort of situation. But let's have a little bit more of a think about just how valuable account management as a service can be. Let's have a look at everything that you would have to do with your account management if you're running it yourself. First of all, keep in mind that account management can take many different shapes. We just saw Active Directory, but consider what account management looks like when it's actually built into the software that an organization is running. So for example, if they're building an application that requires registration, do you really need to write all of that yourself? And yes, modern web frameworks can make this a lot easier, but you're still going to be responsible for it unless you're able to outsource that into an account management as a service sort of model. Beyond registrations, things like password storage. This is not necessarily an easy thing, and certainly it comes with some pretty serious risks as well. We very often see data breaches that result in individuals' usernames and passwords being disclosed publicly. So managing passwords, no matter how well the storage is done, is actually a significant responsibility. Think about some of the other things that you need to build into an application in order to do account management. For example, password resets. We need to make sure that people can reset their password if they forget it. But how do we make sure they do that securely? Do we need to build the whole thing, or can we use account management as a service? Same for password change. So someone's already authenticated, they decide to change their password. There's got to be a process of verification, then of course cryptographically storing it in an appropriate way, and possibly other account logistics like tracking when it was changed, making sure you're not reusing previous passwords. There are a lot more logistics behind most of these boxes than what immediately meets the eye. Brute force protection is another one. We know that account management facilities are often the target of brute force attacks, because attackers are trying to figure out what are the credentials of the individual or individuals that they're testing. So they want to break into your account management. Do you have brute force protection built into that? Or is that something that can be delegated to a provider of account management as a service? And finally, as I touched on earlier, multi-step verification. This is becoming a really critical part of account management because we know how prevalent it is for people to reuse their credentials or choose bad passwords or put them on a sticky note on their PC or some other form of practice which puts the account at risk. Now, it's not necessarily hard to build multi-step verification into an application, but when there's a turnkey solution that does all of these things together, and it's simply part of account management as a service, then that can make a lot of sense. This is a cloud computing security strength, because you can go to a provider like Microsoft and get this out of the box, implemented in a very strong, secure, proven fashion, and not only save a lot of effort in building it yourself, but also be able to have confidence in the effectiveness of how it's been built. So that's account management as a service. Let's go and look at something a little bit different now. Let's go and look at VNets on demand. We're going to take a pretty brief look at how to create a VNet in the cloud. And what I really want to demonstrate here is that something that used to be quite a bit of work on premise, something which often involved physical equipment that you'd have to manually configure and actually physically set up, is now a commoditized service. So for example, in my Azure portal, I can jump up and create a new resource, and then as that loads, I have an option down here to jump into networking. Now, a virtual network is going to be pretty much as Microsoft explains it here. It's a logically isolated section within Azure. So think about your own network that's segmented off from other tenants. We'll go down and just create a new one. And what we're going to see here now is the configuration for the service. We're not going to go all the way through and create this, but we're only a minute or two away from being able to do it. And this is really the whole point of some of the options that cloud gives us for security. We know that practices such as network isolation are really important parts of a robust InfoSec strategy. When it becomes this easy to provision your network and to properly segment it by using things like VNets, suddenly managing and isolating resources becomes a lot easier than what it's ever been before. Have a think about what would have been involved just to get to this point in that old on-premise model. It wasn't an easy task. In the cloud, a VNet is just a service. And just like prevention from DDoS attacks, server administration, or account administration, this is just one more thing that you simply turn on demand, and then pay for as you use it. So that's VNet on demand. Let's now move on, and I want to talk about something that's been really difficult to do on-premise, and that's using a key vault. I want to start off with a definition of a hardware security module, or as we also know it, an HSM. Now traditionally, these were pretty serious pieces of physical infrastructure, and as the definition explains here, they're designed to safeguard things like digital keys, and obviously they're stored in a very cryptographically strong fashion with appropriate authentication and authorization controls. An HSM, as a dedicated physical machine, will be resilient to things like tampering, because inevitably that's what an attacker wants to do. They want to get the keys out of the device. But the HSM is designed with the express purpose of storing them in a cryptographically secure way. But these are serious pieces of gear. They're enormously expensive. And what tends to happen in many organizations is things like digital keys are insufficiently protected. They may not be cryptographically stored, and they may be accessible by too many people. However, let's have a look at what we can do when we move into the cloud and use a feature such as Azure's Key Vault. In a Key Vault as a service model such as Microsoft provides with Azure, we can have this concept of security operations, so someone who is actually in charge of the keys. This is not going to be your developer or someone in the role of actually building software, but it's going to be someone whose express purpose is to look after this valuable asset. Now, of course, we'll still have the developers and the IT pros, so the people that are building and deploying the software. But when we have a Key Vault model where there's a dedicated security operations group that maintains the keys, then the developers and IT pros never actually need to see them. They focus on what it is that they do well, but they never see the keys, and that means they never see the data that the keys protect. Now, all of this is auditable as well. So we'll have someone here that can actually go back and review who has access to those keys, and is it compliant with the appropriate data security standards. So now key management becomes not only a very secure process in terms of how that valuable information is stored, but a very traceable process, because everyone has a discrete role and their actions are carefully logged. Let's have a look at how it looks in action. There's quite a bit going on here, but in a nutshell, we're looking at how SQL Server running in Azure can use the Key Vault in order to protect the keys that are used to unlock data at rest in that SQL database. So you'll see here, we've got our SQL Server administrator up in the top left, managing the SQL Server instance. And then we've got security operations and the auditor over there towards the right, who do their own discrete tasks in terms of how they manage the Key Vault. That SQL administrator configures the database to be able to communicate with the Key Vault, but they never see the keys themselves. This is the premise of the Vault, the ability to make sure that only the right people get access to this very sensitive data. This is all configurable as a cloud service. It's a measured, on-demand self-service that's rapidly elastic. It adheres to all those usual characteristics. And they're all things that the traditional physical HSM on-site never did very well. So now we've got this situation where organisations that never would have had an appropriate strategy have easy access to doing it the right way. And that's the joy of having a Key Vault as a service. Now, I've just mentioned auditability a couple of times. So let's move on and have a look at just how much visibility we get into what's been happening within a cloud environment. So back here in my Azure portal, I want to have a bit of a look at auditability. So what I'll do is scroll down and browse the resources I have available on the site. Now one of these is the audit logs. And within my audit logs, I get a nice rich history of all the events that have been going on within this cloud environment. So for example, as I scroll down a bit, I can see up the top an update to the autoscale settings. I've listed a bunch of resources, I've updated my SQL database, and I shut down a virtual machine a little bit earlier as well. We can see that these are mostly informational, but then as I scroll down a little bit further, I can also see there's been an error when I attempted to update my hosting plan. That was a couple of days ago, but let's go and take a look at it. All of this information is made available by virtue of the fact that every single one of the actions you see here in the audit log is something that I had to do within this Azure portal. In years gone by, there'd be many actions which would circumvent all sorts of auditability and logging within an organization. Perhaps a server configuration wasn't documented. A machine was shut down and it wasn't recorded who did it. Indeed, when it's in a data center, it may have physically been someone resetting the device. It's hard to get auditability on that. Now, when we look at this event, the Update Hosting Plan event, which is in the section on the right of the screen, we can see two separate events there. We can see Update Hosting Plan Started, and that's got a little blue informational icon next to it. And then a little bit further up than that, so a newer event, we have this error. Let's drill down. What we're seeing now is quite comprehensive information about what happened. So a couple of days ago, the caller, which is me, my email address, attempted to perform an update hosting plan operation. When we scroll down a little bit, we can see that our substatus was a conflict. And alongside that, we've got a raft of information about the resource group and the provider and other information that will help us understand precisely what happened. Towards the bottom, we have our properties. And it explains here that the reserved instance scaling request cannot proceed until pending scaling actions for this subscription are completed. I tried to change scale before a previous scale request was finished. That's all it was. But it's logged, recorded, and auditable. Everything of any significance you do in a cloud-based portal like Microsoft's Azure is available for review in this fashion. This is absolutely a security strength. And whilst we've certainly had auditability of various services in various ways in that old on-premise model, this takes it to a new level because the whole thing happens implicitly for every action of any significance. As I've said many times already throughout this course, I am giving examples from Microsoft's Azure, but what I want to focus on more than who the individual provider is the fact that the cloud, as a concept that's very well implemented by a number of different very good providers, provides the ability to do all of the things that we've just seen in this module in ways that were much harder, if not impossible, either logistically or financially, without access to the cloud. So, that's auditability. Let's go on and summarize the module. The nature of the cloud being an on-demand self-service resource means that consumers of these services need the administration facilities to be able to create those resources. And at multiple times already throughout the course, we've looked at the administration portal for Microsoft's Azure platform. Now, back in the module on cloud computing risks, I talked about compromise of administration facilities and the fact that if an attacker gets into that admin portal, they can do some serious damage. That can mean exfiltrating data, tampering with data, or spinning up expensive resources on behalf of the service owner. Protecting the portal is really essential. A fundamental first step for anyone who has any access to cloud administration portals is to strengthen the account that they're using to access that resource. So for example, when I work with Microsoft's Azure portal, I'm using my Microsoft account. Now, all the fundamentals of good account management apply here. In fact, they're extra important when we're talking about accessing administration portals. So things like having a strong, unique password that is not reused anywhere else and is not likely to be guessed. That pretty much goes without saying. But the other thing you want to make sure you're doing with any account that accesses a resource of this value is to turn on multi-step verification. So for example, for Microsoft, we can go to account.microsoft.com/privacy, and then we have a more security settings link. Now within this link, if I drop down one page, we have two-step verification. And as you can see here, my account is protected by two-step verification. This is an absolute no-brainer, and it should be done on any account of any value on any service, let alone the account that controls cloud resources such as my Microsoft account. You can do the same thing with Google and Amazon and all the other big providers protecting valuable stuff. And turning on two-step verification ensures that even if that strong, unique password is somehow compromised or obtained by an attacker, in and of itself, it can't get them access into the portal. So start here. It's the number one thing to do. The other thing we're going to do whilst we're talking about securing the portal is go and have a look at role-based access controls. Let's look at that now. In many of our information systems today, we have this concept of role-based access controls. So let's create roles that have access to certain resources or can perform certain tasks, and then we will place individual users in those roles. So for example, back here on my portal, I'm going to jump into that Hack Yourself First website again, and then within this resource, I can go over to the icon here that represents access controls. Let's drill down on that. And keep in mind that I'm looking at just one resource here, the Hack Yourself First website. But you can apply role-based access controls within Azure's portal at very different levels, all the way up at the subscription level, or down at the resource group level, or on individual resources themselves. So you can start to divide down those cloud resources into logical groups of people who control them, and then decide who should be able to do what within that collection of resources. So we've just drilled down into the users list of the Hack Yourself First website. Now at the moment, there is one access control, and that is simply that the subscription admins are in the owner role. Now we can go and have a look at the other roles that are available within the system, and they're very typical security constructs. Who owns the resource, who can contribute to it, read to it, and so on and so forth. Let's quickly close that blade though, and go back and have a look at what happens when you add a user. Now we can choose the role that we'd like that user to be in. So for example, we might decide that we would like to give someone reader access so that they can view everything but not make any changes. So for example, they might like to view the reports of how the infrastructure is performing, but they won't be able to modify anything. We'll choose reader. And now it's just simply a matter of adding users to that role. So I could have added another user into the portal and then dropped down here and simply added them to this role so that they can view the stats on how my infrastructure is performing. And role-based access controls really is that simple. The problem I see with many organizations that are using cloud is that they simply give everybody access to everything. And this is the whole point about ease of use. Yes, that does make things very simple. However, there's an obvious risk there that when anybody can do anything, you might well find that some people do actually do much more than what they should be doing. So role-based access controls are a fundamental step when giving anyone access to an administration portal like this. So that's a couple of quick tips on securing the administration portal, and both two-step verification and those access controls are explicit steps that you have to go through and do. They won't be configured out of the box. Let's now move on and have a look at hardening the configuration. I want to touch on a few different areas of cloud configuration that are easy to harden. So for example, looking at how secrets are being stored. Now there are multiple levels we can talk about here. So for example, are secrets just stored in configuration files in the application? Might that pose a risk if, say, the source control repository is exposed? Or might that mean that the developers have access to those secrets in the source code? Conversely, is there a native paradigm within the cloud service to store those secrets? Let me show you what I mean. I touched on this earlier on in cloud computing risks, so let's just have a quick look at it again now. If I drill down into the Hack Yourself First website, and then scroll down to my application settings, further down this particular blade, I have things like my app settings and my connection strings. This is the construct that Azure provides to store secrets. Here's the one we looked at earlier on, the app setting called mySecret with a secret value. Now this is sort of a bit of middle ground security-wise. We get the secrets out of the configuration files, away from the developers, away from the source code. However, they are also retrievable here via the portal, so there is a bit of a risk there. The more secure route, whether it be via Azure or by another cloud provider, is to look at what sort of key vault implementations are available. So can you put this in an HSM, like I spoke about in the last module on cloud computing security strengths, and actually get it away from being redisplayed anywhere in plain text? So have a think about the options that are available for the way secrets are stored. The next one to think about is whether any unnecessary services are running. Now this is a security premise which holds true no matter what sort of environment you're in, cloud computing or a more traditional model. You don't want to be running services that you don't need, simply because if those services possibly have some sort of vulnerability in the future, that could leave you unnecessarily exposed. You may also find there's actually some performance gains by disabling unnecessary services. But the real point here is to try and rule out potential attacks by anything that doesn't absolutely positively need to be there. Let's jump back to the Azure portal again, and I'll show you what I mean. We were just over here in the application settings looking at how to store secrets. But if I scroll up a little bit here, we'll notice that there are a number of general settings for other services. Now what you can see here is things like the version of the .NET framework I'm running. We can also see the PHP version. Now the reality of it is that I don't need PHP on this site. I could turn that off. So here's the ability to disable a service that I simply do not need. So let's disable PHP. Java is already off, as is Python. And finally, my WebSockets are also off. I'm not using any sockets for this application. So let's go and save that configuration, because I have been able to strengthen things just a little bit by disabling PHP. Look at what is enabled within your cloud environment. You may not be able to disable everything you don't need, particularly in a platform as a service style model. You may still be subject to what your cloud provider wants to run on the platform. But where available, go and disable anything you don't need. The next one here is excessive database writes. And this is a really good example of this juncture between usability and security. Let me show you how easy it is to make this mistake within Microsoft's portal. Let's imagine we're going to add a new resource. Now the resource that we're going to want is going to be a database, which is down here in data and storage. And we'll just go and take ourselves a SQL database. I'm just going to jump down and select the server and say, let's create a new server. And what you're going to see here is the ability to give our server a name, which is fine, and then create a server admin login. What actually happens when you create this login is that you have an account with the maximum possible rights. It can do absolutely anything that you need it to do in order to manage that database. The risk that I very frequently see here is people then use that account not only to set up and configure their database, but for the web application to connect to it. So now what's happening is you're getting anonymous users browsing the website and then causing that website to make connections to the database using an account that has elevated privileges. This is a real risk for things like SQL injection. So what needs to happen in the Azure environment is that you have to then go and create another login with just the permissions it needs. So you need to apply the principle of least permissions. This is an explicit step. It is something that you have to go and do above and beyond just setting up a new server. And because of that, it very frequently doesn't happen. But that's a pretty important part of hardening the configuration. Let's go and look at one more thing. One final thing to think about is who can actually purchase resources. Now this is really important, and it also relates to the role-based access controls I spoke about earlier. At multiple times already through this course, I've touched on how easy it is to provision cloud resources and how expensive they can get really quickly. We looked at things like economic denial of sustainability when resources become over-provisioned. So you want to be very, very careful about who actually has the ability to create resources. Because as we saw in that earlier example where someone published their private key into GitHub, you can rack up a very large bill very quickly. Not only that, but this can go the other way too. Someone who can purchase resources can usually delete them as well. So whilst this does relate back to the previous clip on role-based access controls, I wanted to call it out again here because it is so essential. So think about who has control of purchasing. That's hardening the configuration. Let's go and look at something a bit different. One of the great things about the nature of the cloud is how it can commoditize and make easily accessible all sorts of services that would have actually been really, really hard to obtain in a pre-cloud world. So for example, we used to put a huge amount of effort into disaster recovery and business continuity plans, not least of which because it's hard to have things like off-site backups and the ability to roll over into other infrastructure in a remote location should there be any catastrophic failures within a data center. When you're in the cloud though, you start to have a bunch of options about how you're going to respond in the event of a disaster. Let me give you an example of what I mean. Let's go and take a new resource, and we'll drop down to data and storage, and we'll take a new storage account. So this is Microsoft's concept that has blobs, tables, queues, and file storage. They have those 4 different constructs that all sit within this umbrella of storage. Now here's what's really neat when you create storage in this as a service sort of way. We can drop down to replication and choose where we want our data to be replicated to. So for example, do you just have locally redundant storage? In which case Microsoft will keep 3 different copies of the data within one data center. So you still have plenty of redundancy, but it's all there in that one location. Or do you go to zone redundant storage, where now the data is replicated into a different data center? So you've got a little bit of redundancy in case there's any sort of catastrophic failure within one data center. Alternatively, you go to geo-redundant storage, and now it's not only in another data center, but it's in another data center in a remote location. Now, none of those models allow you to actually read from the data in those other locations, unless you go to read access geo-redundant storage. and now your data exists in two geographically disparate locations, and you can read from that second location. So that starts to give you options about how you fail over to somewhere else should something catastrophic happen. From a disaster recovery and business continuity perspective, this is a really valuable service. And it's also very valuable as a protection against numerous security threats, because we've actually got the data in a remote location as well. So in the case of, say, destruction, there's another copy in another location. And further to that, most good cloud services also have numerous backup options as well, versioned backup options. So the point I'm trying to make with all this is that paradigms such as storage redundancy can be enormously useful if you go and configure them appropriately in the portal. This is a feature that was very hard to implement in the pre-cloud world, at least without spending large amounts of money. So that's data replication and redundancy. Let's go and take a look at how we can harden our communications over the transport layer. In the previous module on cloud computing security strengths, we looked at VNet on demand. So how you can create a logical virtual network just simply by going through the cloud provider's portal and literally setting it up on demand. Now that's a great strength of the cloud, security-wise, the ability just to create these logically isolated networks. But what we want to do now is when we're connecting to that network, to do so in the most secure fashion possible. And to do that, I'd like to have a VPN between my on-premise environment and my cloud environment. The value of the VPN is it's going to give us an encrypted tunnel between those 2 points. So even if we're using a service which doesn't natively encrypt on the transport layer, so let's say we're just doing plain text FTP, by routing through a VPN tunnel, we now start to get encryption across that connection. It would still be advisable in a case like FTP to use secure FTP. There are some other risks that still persist. But the premise of someone getting in the middle of the traffic, somewhere between your premise and the cloud environment, now becomes a non-event. Let's have a look at how this works. I'm going to jump up to New, down to Networking, and earlier on I drilled down into the virtual network option here. This was where we could create the VNet. Instead though, when we're talking about VPN, I'm going to get down to the virtual network gateway option. And this allows us to connect our VNet, the one I talked about in the previous module, with our local network. Now it's quite easy to set up within the Azure portal. I've found there's usually a little bit more configuration involved on the other end, so on your on-premise end. But the point I wanted to make here is that there is an easy self-service on-demand mechanism on the cloud side of the service for setting up a virtual private network. Do this if you're going to be having communications between your on-site premise and a VNet, because it's going to give all of those connections and the communications that you have between those two environments that extra level of security. And again, this is something which won't be configured out of the box. You have to go in and set this up, but it's there if you choose to use it. So that's one way that we can further secure the transport layer. Let's go and have a look at something quite different. And that's identifying SQL injection attacks. One of the great things about the nature of the cloud is it makes it very easy for the cloud provider to add security features as you go along. Cloud services are evolving really rapidly, and it's a very competitive environment as well. And what you'll often find with many of the cloud providers is new features being added very quickly to try and give an advantage across all sorts of different areas of the offering. The range of services, the price, the availability, and even the security. So I'll give you an example here from Azure. I'm going to go and drill down into the Hack Yourself First database. Now this is a SQL as a service database. I don't have my own SQL server, it is just simply a SQL database that they manage for me. I'm then going to jump over here into my settings blade and choose auditing and threat detection. And one of the services that Microsoft has added here, well after the service actually launched, is threat detection. And as you can see here, threat detection is going to detect anomalous database activities. And the activity that we're going to identify in just a moment is SQL injection. So let's go and turn this on. And if we scroll down a little bit, we can see the types of threat it's going to detect. All of those are pretty self-explanatory. So we'll accept that. And then the alerts are going to be sent to my email address. Let's now go and save this. Right, now that that's done, I'm going to go away and use an automated tool to launch a SQL injection attack against this site. Let me go and do that, and then we'll see what Azure has been able to identify. So I've just finished launching an automated SQL injection attack against that Hack Yourself First website. And as soon as I started doing that, I got this email from Microsoft. Potential SQL injection was detected on your database. And if I scroll down a little bit through this email, we get a bit of info about the event that it observed and a link to drill down all the way into that one individual event so we can see what happened. But instead of doing that, let's go and have a look at the portal and we'll see what it's reporting there. So back in our auditing and threat detection blade, I'm going to jump over to the Explore link just here because I want to see what events it's managed to find. Now we can see a bunch of results here, including some successful results as well. Auditing is not just about capturing things that fail. But what I want to do is go and take a look at one of those failures. So let's grab this one here. Now we start to get quite a bit of information about what the event actually was. And if we scroll down a bit further, we'll see the SQL statement which caused the failure. Now in this particular case, my web application has a SQL injection vulnerability in the order by clause. And in fact, everything from here down to here is malicious SQL syntax which was injected by the SQL injection tool. Now, none of this actually stops the SQL injection attack. And indeed, knowing what is a genuine request versus a potential attack is not always a simple thing. So in this particular case, threat detection is really an early warning system that allows you to identify the occurrence of an incident like this and then determine if any action is actually required. Now, there are dedicated firewalls available, web application firewalls, that are very sophisticated tools that are very adept at looking for this class of attack. And as it turns out, tools like that are available as a service in the cloud as well. So as valuable as services like auditing and threat detection are, and you should enable those on your cloud as part of hardening the cloud, we can go a lot further than that too. Let's go and look at a security as a service offering. This is a Barracuda firewall. It's a pretty serious piece of equipment. You put this in your on-premise data center and you route traffic through it such that any potential attacks, like what we just saw with SQL injection, are identified by the Barracuda firewall and blocked before they hit the web application. This requires quite a bit of sophistication. The device needs to make sure it properly identifies and catches attacks without letting through potentially risky traffic, but also ensuring that legitimate traffic does get all the way through and is not identified as a false positive, thus disallowing an otherwise good request. Equipment like this is not cheap. It's a serious investment for an organization, and it is a physical appliance, which means that you're doing all sorts of capacity planning assessments and locking into a piece of hardware for a long period of time. But we can now get this in the cloud as a service and use it to harden our implementation of cloud. Let me show you what I mean. This is the Barracuda web application firewall as a service. So think about that physical device we just saw, except that you never touch it. It just runs up there in the cloud and it does the same thing in terms of your traffic is routed through it and it identifies potentially malicious traffic and blocks it, except that it's simply something that you turn on demand and pay as you use. Now what this means is that when we scroll down a bit and look at the service offering, we can choose, for example, what sort of scale we'd like. Now what this means is that you can simply choose the instance size that you need for your organization. And then when you choose that instance size, you'll pay for it by the hour. And as you can see here, that may mean as little as just over $1 an hour. So now, rather than paying upfront this large capital investment of many thousands of dollars, you can get started for a very small amount of money. And then you can scale up as required as well. So what if we start going down to larger instances? What if we went all the way down to the G series and we took a G5 Barracuda web application firewall and paid more than $15,000 a month for it? That is a seriously large amount of money, but it supports a seriously large scale too. And the beauty of having this in the cloud is that we can choose a G5 when we need it, but when we don't need that much capacity, we can scale it back down to one of the cheaper options. Let me show you how easy it is to deploy. We're back in the Azure portal. I'm going to add a new resource, and I'm just going to type Barracuda Web, and here are our firewalls. We'll go down and grab the Barracuda Web Application Firewall at an hourly rate, rather than bring your own license, because I want the entire turnkey solution. Just go to the portal, choose what I want, and it's all there. So here's our firewall, and now it would simply be a matter of creating it. Now, of course, there's still going to be some configuration. Your traffic needs to be routed through that firewall on its way to the underlying hosting service. But the point is that from a security as a service perspective, this is a case where we simply turn up to the portal, provision the resource, and then configure it all online. When we look at this as part of the strategy I've been discussing in this model of hardening the cloud, you start to see how easy it is to tweak the configuration and provision additional services to make a cloud deployment a really, really robust implementation. And you can do this in ways that you could never do in that old premise environment. Certainly not in any time-efficient, cost-effective sort of fashion. So security as a service is the last thing I wanted to touch on here. Let's now go and summarize the module.